What I want to do is point out some of the issues that we're dealing with once again within this field. And the first one is some career opportunities and how you can get there. And the second is the 6 different disciplines that will allow you to get to different careers in IT or in ICT. And then at the end, we'll have some time to talk about what's available here at the local community colleges. And we'll also talk about what's available at the universities as well. Computer-related terminology, computer science, we've mentioned, and that's what you hear in school. So when you sit down with a counselor, they're going to say, hey, you know, I'm interested in computers, there's computer science, and here's what you need. Does anybody talk with a counselor about computer science, maybe a career in computer science? Maybe not yet, okay. So, and the counselors will know about computer science, because that's what everybody's talking about these days. A very popular major at the universities. In fact, they've got so many people applying for computer science programs right now, they have to turn some of them away, which hurts me because my primary job as the regional director for employer engagement is to make sure that our employers have enough people that they can employ. So if the universities aren't putting through as many people as I want them to, as I need them to, that makes it more difficult for our employers to hire people, which is frankly one of the reasons that we do these CyberCamps. We want to make sure that you guys know that there's awesome opportunities available to you guys in high-tech careers in ICT. And if you're enjoying what you're doing this week, then hopefully you'll, one, join a Cyber Patriot team in the fall, if you haven't already planned for that. And Mr. McNally can help you with that as part of our Center of Excellence for Cyber Patriot out of Elk Grove Unified School District, even though that's for the entire region. But we've got some great folks who can help you with that. But then hopefully you're going to start thinking, hey, when I go to college, what major do I want to study? So I can hopefully get myself into a career in computing. Notice I'm using computer science, I'm using computing, and does anybody's parent or uncle, anybody in your family work with computers, like on the job? Anybody? Okay. Now, do they say that, like, when they tell people what they do they say, like, I work in computer science? Do they say that?
Oh, my brother just recently graduated with a computer science degree.
Okay, so your brother, yeah? Okay, now, interesting you would say that. So he graduated with a computer science degree, but he's doing IT work.
Well, it's just like, you know, general.
But that's what we call it, right? So we have a difference in nomenclature, whereas in academia, we refer to a lot of this as computer science, especially at middle school and high school. And once people graduate, then they work in IT, okay? And that's something that's, it can be difficult for people who are not sure. I'm one of those folks, frankly, even though I have degrees in computing, and I won't quite give away where those are yet. We'll talk about them as we go through. But my parents didn't go to college. My parents had 10th grade educations. I grew up in Germany. My dad happened to end up, fortunately, at a company called IBM. Have you guys heard about IBM? Big computer company, okay? But he couldn't tell me about the different pathways that were out there. So I was fortunate to end up where I did, because all this terminology is not something I was familiar with. So hopefully by the end of today, you'll know what the different options are for you guys. So here are the 6 different disciplines that we're going to be discussing briefly. We're going to talk about computer engineering, computer science, information systems, also known as management information systems, information technology, software engineering, and cybersecurity. And you may wonder, okay, these all sound rather technical. How different can they really be? And you might be surprised, even though a lot of companies, when you look for a job ad that's out there, if they're saying that they want somebody with a computer science degree, more often they'll say degree in computer science or equivalent or similar major. So just because you're going down one route, that doesn't mean that that's going to be your one-time decision that's irreversible. There's a lot of options to move back and forth. Let's talk about the big one, and that is computer science. In computer science, you are going to be programming. You are going to be dealing with various facets of computing. And to keep you as flexible as possible, and frankly, because of some historical conventions that we've had, they're going to therefore make you take a lot of math. Is anybody here in calculus already? Anybody taking calculus? Not in this class, okay? Anybody planning on taking calculus before they graduate from high school? Okay, it's about half of you here, okay? Again, American River, I'm not sure how many of you there may be, but here at CRC, it's about half. Why? Why are they making you take calculus? Do all of you guys want to go into science and engineering? Who in here is planning on taking calculus who doesn't want to go into engineering? Yeah, I was one of those people as well. No, for me, I graduated high school early, so I started calculus in college. But I went through the first 2 courses of calculus. It's like very interesting math. It makes you think differently about how math works. Like the math that you're probably studying right now, like algebra, okay, it kind of defines what things are, and you're looking for variables, right? Whereas calculus, you can see like trends and the way things change, okay? So it's a very different kind of math. And if you're going to be in engineering, especially in computer engineering, which we'll get to in just a second, you're going to need calculus. Interestingly, most people who graduate with a computer science degree and do a typical programmer, analyst, system analyst kind of job will probably never see calculus again in their career. You're kind of like, well, why are they teaching it at the university? Part of it is historical, because computing comes from math, so the math makes sense, right? The other reason is they want you to learn logic. Notice one of the things that is on the slide right here is logic design. And they use calculus to teach you that. It's not the only way to teach that, but that's what a lot of programs still do. So if you're going to be in computer science, they're going to make you go through a lot of math. Which again, if you like math, power to you. It's a great way to learn some great skills that some of which you're going to be able to use in your career. Now, programmers is one of the things that you're going to do when you graduate with a computer science degree. Except, what do you think programmers do? Do you think programmers sit at a computer all day and all they do is type code? They don't. In most cases, they meet as part of a team, because in most cases, programmers don't work by themselves. They work with others, so there needs to be necessary communication between other folks. Sometimes they'll meet with users for specifications to make sure that what they're doing is correct. There's testing involved, and you need to work with other people who will probably, hopefully you won't be testing your own code, other people will be testing your code. So it's not just people sitting at a computer and staring at a screen all day, which is good, because anybody here likes doing that, staring at a screen all day, doing nothing else? I'm assuming most of us aren't quite that way. Okay, so and it's not. I mean, oftentimes computer scientists are these geeks, right? These skinny guys with white skin who haven't seen sunlight in the last 3 months. Okay, it's not like that. It's really not like that. Now, I'm very happy to see here, and I don't know what it's like at American River College at this point in time, but I'm looking at a classroom here in front of me that has about 2/3 ladies, which is awesome, because we need more of you in the technical fields. That's not typical for a typical computer science workplace or IT workplace right now. So just frankly, I'm thrilled that there's so many women in this room looking to learn more about computers, about ICT. That's great. So again, computer science, the big major, it's available here at CRC, at really any community college in the area. A couple of exceptions, but it's there, and it's certainly available at most four-year universities, and very much established as such. The second discipline, besides computer science, are you guys taking notes, is software engineering. Now, software engineering is an interesting one for us because there are not very many software engineering programs on the West Coast. They tend to be more on the East Coast and in the Midwest. So if you want to go away to college, that's going to be more of an alternative to you. On the West Coast, we tend to teach software engineering at the master's level. Now, let me ask, you guys know how many years does it take when you start college to get to a bachelor's degree?
4.
4 years, typically. In computer science or some of these computing fields, oftentimes it's more than that. And I saw the number 6 put up. That's almost more realistic, okay? But they're hard majors. They're very full majors, have a lot of courses in them. So sometimes students take more than 4 years. That's not atypical at all, okay? Now, a master's, how many more years does it typically take to get to a master's after your baccalaureate degree? hopefully less than 3. You should be able to do it in 2 years, okay? Now, some people take more than that because they're working already, right? So some people will go, they're on the job and they come back and they go part-time. So it takes a little longer to get the master's, okay? That's very common as well. By the way, did you know that you can get a doctorate degree without first getting a master's?
Yeah.
Okay, I wish I had known that. And I didn't find out until the 2nd semester of my master's program that was possible. Again, my parents didn't go to college. I just didn't know. So now, who needs a doctorate degree in really anything, but especially in this kind of a field? If you wanted to teach at a university level or if you wanted to do research, that's when a doctorate degree becomes necessary. If you're going to be a practitioner, if you're going to be working in the field, chances are the bachelor's will be just fine to certainly get you going for the first several years. And then later on, what a lot of people do as they go into leadership, like say they become managers of a programmer team, they might go back and then get some kind of like a master's in business administration or some kind of a management degree to be able to pick up some additional skills. If you want to stay technical, some people will go back and just pick up new skills or more specialized skills. So you're seeing master's degrees in data science, for example, right now, which makes a lot of sense for somebody with an IT degree. Or you might see master's degrees, actually oftentimes computer engineering. If you want to go into some greater details, you might have master's degrees for that as well. Okay, so software engineering, not too different from computer science. You still have a lot of the math requirements. They look at things at more big picture. So rather than look at individual programs, they look at systems more so than in computer science. The third discipline is computer engineering. And what do you think a computer engineer does? Yeah? Yeah, they make computers, they build computers, okay? So computer scientists program them, software engineers tie them into systems, and computer engineers actually make them, okay? So I'm here with one of those little clickers that I have to advance the slides. Is this technically a computer? Yeah, it's more of a peripheral, right? You could argue, does it accept input? Yes. Does it produce output? Yeah, kind of. Does it store things? Not really. So this probably would not be a computer in and of itself. But chances are, do you think it has like some chips and like a little circuit board inside of it? Yeah, it does. Okay, so that's what computer engineers do. Now, do you think they need math? Do you think they need physics? Absolutely. Because if you want to move electrons around a chip, you need to know how those electrons behave. You need to know how quickly they're going to move, and you need the science background if you're going to be a computer engineer. Absolutely. Okay. Now, some of the companies that these folks work for, you might be familiar with. Has anybody heard of a company called Motorola? Okay. So everything from cell phones to radios to. Has anybody heard of a company called Intel? Where's Intel's headquarters? Anybody know? Yeah. Actually, you're thinking about the location in Folsom, and you're right. There is a big Intel location in Folsom. That is their worldwide IT headquarters. But the actual company headquarters is in Santa Clara, near San Jose. But you're absolutely right. There's a big facility right here in the greater Sacramento region, out in Folsom. Okay, but right off of Highway 50 there, right near Rancho. Has anybody been to Great America, the amusement park in Santa Clara? So if you want to know where Intel's headquarters is, when you're on the Demon, which is one of the roller coasters at Great America, if you're going through the first 2 loops, if you look right, that's Intel's headquarters. So it's right there. Okay, so it's not too far because it's Silicon Valley, right? That's where a lot of the computer companies are located. Has anybody heard of a company called AMD? What does AMD do? Yeah, do you know? No. No? Anybody? So they also build chips. It's a competitor to Intel. Okay, anybody know where they're located? They're located in Sunnyvale. If you look out the window at Intel's headquarters, you can actually see AMD's headquarters. That's how close those companies are. And, I mean, not right there, but a few miles down. So a lot of computer engineering happens in Northern California, specifically in what we call the Silicon Valley. Anybody been to Stanford University? Okay, so you've been to Stanford. That's Palo Alto. That's kind of the northern part of, you go down San Jose State, University of Santa Clara. That's Silicon Valley. Actually, I went to a community college in Cupertino, which company is headquartered in Cupertino? Yeah?
Isn't that Apple?
It's Apple. You're absolutely right. Yep, Apple's headquartered in Cupertino. So actually, I had the privilege of working on an Apple II computer, and it was a 2E, in the mid-1980s when I was at my community college. And that was pretty cool at the time. There weren't too many community colleges that used computers heavily, and the Anza College certainly did right in Cupertino. All right, the fourth discipline is information systems, sometimes known as management information systems. And that's what I have my degrees in. So my bachelor's degree is in MIS, but that's technically not correct. If I should have brought it in. My degree actually says on it, it's from Cal State Sacramento, exact state, it says Bachelor of Science in Business Administration, and then underneath that, parentheses, it's a concentration in Management Information Systems. So hang on, Dr. G, what did you do that's different from computer science? Well, in MIS, it's an applied use of computing, specifically as you deal with business. So when I studied computers, I studied them in the context of business. Now, I wouldn't have, known to look under business for a computing kind of degree. And very fortunately, a dear friend of the family who was a business finance major at San Jose State University at the time, he says, Marcus, because I was registered as a computer science major and accepted at Sac State. But before I started, he said, had you thought of MIS? I'm like, what's MIS? He says, it's still kind of computers, but it's in business. And I had gone through 2 quarters of engineering calculus. And frankly, for me, there came a point in time where I didn't care what the rate of change of speed of the rocket was as it was going into space. To me, what was more important was, what's the payload? Why is it going up there in the first place? What is it supposed to meet up with? Okay, so for me, the business background, the applied way of studying technology, was a whole lot more interesting. Here's one other very big catch. You don't need a whole lot of math when it comes to calculus in an MIS degree. You take 1 semester of business calculus and 1 semester, actually at Sac State, they'll have you take 2 semesters, 1 in the first 2 years, 1 in the second 2 years, of statistics. Anybody take statistics at their school or planning on it? Okay, Mr. McNally is waving his hand back there.
I teach it.
Would you agree that statistics is probably one of the more useful types of mathematics?
Yes, the power of estimation.
The power of estimation, if you didn't hear it at ARC, okay? I couldn't agree more. So a lot of stats in business, because it's useful there. And again, if you don't like the depth of the math that you get in calculus, but you like to analyze things and evaluate things, then you can do that within an MIS degree.
Being able to
Predict trends, predicting things, yeah, absolutely. Okay, even though trends, you can certainly do with calculus as well, but with statistics, it's more that probability piece, right? What if, rather than actual numbers.
Yeah.
And here I'm telling a math teacher the difference between, and he's just smiling at me, so, all right.
You pass.
Thank you, I'll take that C-. So where do information systems folks go? Well, interestingly, when you graduate, they end up oftentimes being hired for the same jobs as a computer science grad. You would get that programmer analyst, that systems analyst kind of position. Very similar. Again, a different focus. You're not focused on the science and on the math so much. You're focused more on the business, on the application of those computer skills. The 5th discipline is IT, or information technology. And you mentioned earlier, was it your dad you said works in IT? Your brother works in IT, okay? And do you know which specific part of IT? Do you know what he does at work? Not really, okay? But that's okay, because it could be all kinds of different things. Because you won't have people saying, yeah, I work in computer science. The only people who would say that would be professors at the university, or maybe teaching assistants, etc. Because overall, we call it IT. In fact, the rest of the world calls it ICT, Information and Communication Technology. I teach for a university in Germany as well. They call it IT. So you see both. IT is interesting in that it has picked up a lot of the newer technologies that didn't fit into the other majors anymore. So here you see things like networks. You see things like cybersecurity, the cradle of it, even though we'll come back to that in just a second. You see things like databases that were only peripherally covered in some of the other areas, and that's where IT has found its niche. And notice a lot of the folks start in jobs like help desk, Okay, so you may even work on the help desk while you're in college. A lot of students here, certainly at Cosumnes River College, and I know at American River College as well, they work while they go to college. And if you're going to be in a technical kind of job, why not pick up some technical skills along the way? And which, by the way, are relatively well paid, even as a student assistant. You're definitely going to make more money than you would at a McDonald's or work in retail somewhere. Yes, you have to deal with users, which sometimes can be challenging because people will call you when they're frustrated, right? I'm trying to figure this out for 3 hours. Can you help me? And trust me, I used to do help desk, and sometimes people aren't very nice. But but that's where you learn about people and you learn about technology. And here's the sixth discipline. The sixth discipline is the newest one of them all, cybersecurity. Now, hang on, Dr. G. Shouldn't cybersecurity be everywhere? I mean, if I'm writing a program these days, shouldn't it be pretty secure? If I am building a web form in my IT job, shouldn't that be a secure web form? By the way, you guys are studying cybersecurity. Did you know, like, if you go to a form on the web, like you're filling things in, like they ask for your name, right? Like first name, last name. Have you ever thought of putting something different in there? Like just like a bunch of periods or a bunch of commas, a bunch of question marks to see what comes up. Interestingly, there's a very common problem called an SQL injection, where you can actually, instead of typing somebody's last name, you can put in a SQL query, you can put in a database query, and the form will break and it will give you all the data that people have previously entered. So if you're not careful, if you don't practice cybersecurity everywhere, then you may be causing all kinds of issues to your company, which of course then gets very expensive. Thank you, Sean. So, cybersecurity. Now, the specific degrees in cybersecurity will help you configure things like firewalls. Some of the things that you're hearing about this week when you're learning about some of the things that can go wrong. Packets, right? What does a firewall do? A firewall either stops packets or lets them through, depending on the kind of packet, depending on the kind of port that they're arriving on, right? That's what's studied in cybersecurity. And you do some cryptography, potentially, software developing. So if you still want to program, you can certainly do that as well. Speaking of programming, have any of you done any kind of programming yet? Some of you have. Which languages? Just throw them out.
Like program?
Yeah, programming languages.
I did intro to
Python?
machine learning. I use Python and Jupyter.
Okay, Jupyter. Okay, all right. And your other languages? HTML, which is more of a formatting language, yeah, and C. Okay, C is very popular, older language at this point in time, but certainly the foundation for a lot of things. Anybody heard of Python? That's another one that's out there. Anybody know what the most difficult programming language is to learn? Python is not easy for some people, but other people argue that it is, so it kind of depends on your style and your background. I won't leave you hanging. A lot of people in our field say the most difficult programming language to learn is the first one that you're going to learn. Because has anybody here learned more than one programming language yet? You'll find once you've learned one, you can relatively easily move on to the next one. Because once you know how things work, you know the basic structures and how things operate. Once you know how to do it with one language, it's relatively easy to switch to another language. Just like when you learn world languages, right? So I grew up in Germany. I speak German, English, French, Spanish. I studied Latin for 3 years. Once you study one, to move to the others is actually not that difficult at all. And the same thing is with programming languages. Okay, so as long as whatever you start with, even HTML, even though it's technically a formatting language, not a programming language, but the skills you're learning, the syntax, that everything has to be in the right place, the commas can't be out of place, etc. All those skills will be very useful to you as you learn more programming. Mr. McNally, you have a question.
I would be curious to know how many of you in here have dealt with the Scratch programming language.
He's asking how many people have dealt with a Scratch programming language, and about almost half of the people are raising their hand, okay?
And any JavaScript.
JavaScript, anybody? 2 people? Okay, 3?
Wow.
Yeah, okay. Now, Scratch doesn't feel like programming, does it? But hang on, what's programming? Aren't you telling a computer what to do? Okay, so yeah, we don't think of it as such, but Scratch is definitely a programming language, for sure. All right, almost done. So we're going to finish up here. So a bachelor's degree is certainly helpful, though you can do a fair number of jobs, like in IT, for example, for the tech support, with associate's degree as well. How many years typically to get to an associate's degree? 2 years. Okay, and you can only do those at community colleges. Universities don't typically offer 2-year degrees. So now do you have to have a 2-year degree before you can move on to a 4-year degree? No. Okay, it's something that you pick up kind of separately. Okay, I have, like, my associate's degree is in French and Spanish, so it has nothing to do with my tech career, even though it does, as I just explained, the concept of languages. Okay, but it wasn't a requirement for me to move on. Now, in addition to the degrees, sometimes it's very, very helpful to also have what's called certifications. And there are several organizations that offer certifications. CompTIA is an organization that offers what we call vendor-neutral certifications. So you don't necessarily have to know a lot about, say, Windows or Linux. They kind of pick some pieces from different operating systems. You may have heard of the A+ certification or Network Plus or Security Plus. Those are CompTIA certifications. Has anybody heard of Cisco certification, like CCNA? Okay, I see a couple of hands going up. So that's another big organization. And by the way, that's from them I have the prize that I'm going to throw out in just a second. And then I'm sure you've heard of the company called Microsoft. They do certifications not only for their Office products, but also for the server products that they use to maintain networks, to manage networks. Last but not least, are there jobs out there? And again, my primary mission as the new regional director for employer engagement for the region in ICT and digital media is to make sure that we get people who want to do this. And the one thing I can do is I can guarantee you that there will be ICT jobs when you graduate from college. And I stand here knowing that that's going to be an absolute truth. The likelihood of these jobs being sent abroad, like we've tried before, again, is very, very slim. We're getting better at teaching computers how to program themselves, but that too will take quite some time and a lot of people to supervise and to make happen. The jobs will be out there, ladies and gentlemen. So if you are contemplating a career in ICT, I will guarantee you that there will be a job there. And if you, when you finish with your college, 6, 7 years from now, and I will still most likely be here at Cosumnes River College. If you want to come to my office and say, hey, Dr. G, you were wrong. One, I don't think so. And two, I'll be happy to buy you lunch if for some reason you think that I was wrong. The jobs will be there. And not only will they be there, they also pay really, really, really well. I've got a couple of materials for you that I'm going to ask Mr. McNally to distribute if he hasn't already. One is, we have a brochure here on how to get your IT career started. There's what's called the IT model curriculum that's available at all the community colleges in the area. And a great start for you to, certainly at the 2-year level, to get your hands dirty with computers. And then I have a second flyer that, and I will, if you're at American River College, I'll make those available to you guys when I come up there tomorrow. But the second flyer talks about an online certificate in cybersecurity that Cosumnes River College is doing in conjunction with 2 other community colleges in California. And also Sacramento City and American River College have been working on a similar kind of certificate that will allow you to get 1 degree or 1 certificate from 2 separate colleges, just to make sure you get more choices in what you're trying to do. So there's programs that will help you get there, and we'll make sure that you can find out more about these programs by getting some information too.
Could I mention one thing?
Please do, Mr. McNally.
So on the certificate in cybersecurity, this is the one we're referring to today, you'll notice that it provides the median earnings, not the average, the median. I don't know if you've learned what the median is, but that is the middle value. That means half of these people who have this job title actually earn more and half earn less. But it's impressive to me to see what that median value is for these job titles. Let me throw a few out at you. For a cybersecurity specialist technician, the 50 percentile income is $75,000 per year. For cybersecurity analysts, $85,000. For IT auditor, $86,000. And that one IT auditor, there's over 6,900 job openings currently. Obviously, it fluctuates, but that's a lot of openings.
It's not going to go down either.
No. Yeah. We've got an incident analyst responder at $99,000 per year. These are 50 percentile dollar amounts. And finally, network penetration and vulnerability tester, which I believe are the skills that they're starting to learn in this camp and in Cyber Patriot, if they so choose to stay with Cyber Patriot this fall. The median value is $102,000 with over 9,800 job openings currently. So this is brought to you from cyberseek.org, pathway.html, if you want to see what the current numbers are. But it blew me away when I saw those dollar amounts and I saw that demand for those positions.
Yeah.
Thank you.
No, absolutely. And it's not just, that making good money is one thing, but finding a rewarding career is another. Because, you're going to be doing this. You guys are going to be working for almost 50 years. You finish college, you're going to be on the job for probably about 45. I know it sounds like a really long time. I know you have to work for 45 years. That's pretty typical, right? You finish college at 22, 23. For you guys, retirement age is probably going to be about 67, 68, maybe closer to 70 as we all get older. You better find something that you're going to enjoy. Okay? And there's lots of options within ICT to do different things here and there. But you're going to be helping people. You're going to be making a difference. And I hope that that's something that you guys would want to do. One more question before I finish up.
And by having many skills, you're going to be part of the great number of people who actually change their career 3 to 5 times in their lifetime.
If not more. Now, chances are you're still going to be somewhere around technology, especially if you're comfortable with it. But yeah, you may be doing programming for a while. You may be doing pen testing for a while. Lots of different options. All right, you guys find this interesting? Okay, so that said, and I will take the first person. Sorry, AR, I can't see you, so it's just going to be here at CRC, but we're going to do the review either way. I'm going to ask the question, and whoever raises their hand first when I finish the question is the one I'm going to call on. They get a chance to get this very, very special prize that I have right here, which is a Cisco USB hub, kind of cool looking kind of hub. So there are 6 disciplines in ICT that we talked about. What are the 6? I haven't finished reading the question yet. Disciplines. What are the 6 disciplines? Okay, good. I see that hand first. Go ahead. You got to do all 6.
I think one is
Software engineering.
Computer science.
Cybersecurity. It's okay to read them if you took notes. It's fine.
Okay. Computer
Computer engineering.
and
Information systems. And last but not least,
information technology.
information technology. You got it. All right. Good job. There you go. Right there.
Yeah,
All right. Okay, let's give them a hand. You just remember them all. There you go. All right. Well, I hope this was informative. So next time you sit down with a counselor at school and you want to talk about jobs in technology, and the counselor says, okay, well, there's computer science, then work with that counselor to see what would work best for you to meet your interests. And it may be computer science, but it may be computer engineering, software engineering, information technology, information systems, or what we learned about this week, cybersecurity. Thank you very much for your attention. I'll be around here at CRC to answer questions if anybody wants, and I will be at American River College tomorrow to answer any questions that you might have there. All right, thank you guys very much, and take care.